Hi guys. So let's go ahead and work through this review. Remember that each question has the topic that it comes from on the beginning of the question so that you can reference those notes if you need to. So okay, for number one, we're going to factor. All right, on this first one, we can go ahead and factor out a 2. Okay, and 162 divided by 2 is 81. Negative 2b to the power of 4 divided by 2 will be negative b to the power of 4. Now we have the difference of two squares. Remember, we have two identities, a squared minus b squared, which equals a plus b times a minus b. And we have a squared plus b squared, which is a plus bi times a minus bi. So let's go ahead and write our a and b's, right? A would be 9, and b would be b squared. So a is 9, and b is actually b squared. So now that I have the difference of squares, I can factor this into a plus b times a minus b. But after you do that, you actually have here the sum of two perfect squares, and here the difference of two perfect squares. So now we can factor again. 9 as a perfect square would be 3 squared. B squared as a perfect square would be b squared. And then here, of course, these are the same numbers, so it would be 3 squared minus b squared. So here for the sum of squares, remember the sum of squares, it factors the a plus bi times a minus bi. So this final one would be 3 plus bi times 3 minus bi. And then for this one, the difference of squares just factors into a plus b times a minus b. So that would factor into 3 plus b times 3 minus b. And that's it. All right, moving on for part B. On part B, we need to factor, right? But if you notice, the last term and the first term are both perfect squares. I can write the first term as a perfect square would be 10x all squared. The last term as a perfect square would be 9 squared. Now remember the perfect square trinomial, right? A squared plus 2 times a times b plus b squared factors into a plus b squared. And then we have another one that's very similar to this one. It's a squared minus 2ab plus b squared. So it's just the middle term is a negative. If the middle term is the negative, then the binomial is a minus b instead of a plus b. But the important thing is that, yes, the first term can be a perfect square and the last term can be a perfect square, but we need to check and make sure that the middle is actually 2 times that a value, 10x, times the b value, 9. And we have to verify that. So 2 times 10 is 20, times 9 is 180x. So this middle does check out, which means that it is a perfect square trinomial, and then I can factor it into a plus b all squared, okay? And again, it's very important for you to double check, because let's say, for example, this middle term was actually 181x. Then you wouldn't be able to factor it into a perfect square trinomial because it wouldn't be a perfect square trinomial. Okay, so you always check the middle. All right, part C. So on this one, of course, we could factor out a GCF. At the beginning, we could factor out 2x, which leaves us with 1x squared minus 3x minus 10. From there, I do have a coefficient of 1, so this is the easy factoring, multiplies to negative 10, excuse me, adds to negative 3. We would have 2 and negative 5. So 2 times negative 5, 2 plus negative 5. So I'm going to go ahead and factor. This is easy factoring, so it's x plus the one number times x plus the other number. And we're done. Okay, moving on from there, part D. So on this one, we can't factor out a GCF. So we just gotta have to rainbow over because there is a coefficient. So 7 times 18 is 126, right? I'm gonna go ahead and erase these identities. I don't need them anymore. And so, as I mentioned, 7 times 18, excuse me, is 126. So we need to multiply to equal 126, and we need to add to equal the middle 27. So this is a lot more difficult to try to figure out the two numbers. Like here it was a lot easier because it was just multiplying to -10 and adding to -3. But here we're multiplying to 126, which is a lot more difficult to try to figure out. So what I just do is I go through one number at a time. 126 divided by 1. 1 plus 126 does not add to 27. So let's try the next one. 126 divided by 2. Okay, 2 and 63 do not add to 27. And I just continue like that. Divide by 3. 3 and 42 do not add to 27. 126 divided by 4. 4 and that's not a factor. 126 divided by 5 is not a factor. 126 divided by 6. 6 and 21 add to 27. So 6 times 21 is 126. 6 plus 21 adds to 27. So now we need to bring down the first term, bring down the last term, and then we split the middle. Instead of writing 27AB, I'm going to write this as 6AB plus 21AB. And remember that the order that you write these two do not matter. So if I wrote 21AB first and then 6AB after, that's perfectly fine as well. From here, we're going to go ahead and group to factor. So group the first two terms, factor out as much as you can. Group the last two terms, factor out as much as you can. From the first two terms, I could just factor out A, which leaves me with 7A plus 6B. From the last two terms, from 21 and 18, those have a common factor of 3. So I could factor out 3, and I could also factor out a B, which leaves me with 7A plus 6B. Now that we factored out as much as we can, we should, as long as we did the rest of the math correctly, we should always end up with the same binomial on both of these, right? So now we could factor out that 7A plus 6B from both of these terms. So from this term, if I divide that out, I would just get A, and this term, if I divide that out, I would get 3B. And that's how it factors. All right. For part E, okay, we have a coefficient of 1, so this is easy factoring. Multiplies to 10, adds to 11. So that would be 1 times 10 and 1 plus 10. Remember that if the coefficient is 1, you do not need to break up the middle like we did here. Okay, you do not need to break up the middle. You only need to do that if the coefficient is not 1. If the coefficient is 1, then it's just p plus the one number times p plus the other number. Of course, the variable here depends on the variable from the expression. And then last question, part F. So on this one, I cannot divide out 3, so I need to rainbow over. So there is a coefficient here. 12 times 3 is 36. And we need to add to -13. So we need to multiply to 36, add to -13. So if you don't know what the numbers are, again, we're going to go ahead and use our calculator and divide one number at a time. Divide 1, see if that works, then 36, divide 2, see if that works, and so on and so forth. I actually know what the two numbers are. It's -4 and -9. -4 times -9 is 36. -4 plus -9 is -13. So I'm going to go ahead and bring down the first term, bring down the last term, and then break up the middle. Instead of writing -13x, I'm going to write it as -4x minus 9x. Okay. Then I'm going to go ahead and group the factors. So I'm going to group the first two plus grouping the last two. And then I'm going to go ahead and factor out from the first two as much as I can. I can factor out a 4x, which leaves me 3x minus 1. From the last two, I'm going to factor out as much as I can. I can factor out a -3, which leaves me 3x minus 1. Now notice again, once you do this, as long as you do the rest of the math correctly, then you will always end up with the same binomial here, which then you can factor that out. And on the first term, that just leaves us with 4x. On the second term, that just leaves us with -3. And that's factoring. Let's move on to number 2. So number 2, now we're solving, okay? Now there are many methods to solve. The first method that you should always try is by factoring. So I'm going to go ahead and try factoring this one to solve. So, excuse me. If I rainbow over, 5 times 9 is 45. And we're adding to negative 18. Multiplies to 45, adds to negative 18. Will be negative 3 times negative 15, negative 3 plus negative 15. Again, the coefficient here is not 1, so I do need to bring down the first term, bring down the last term, and break up the middle. So I'm going to break up the middle to negative 3x minus 15x. And then I'm going to go ahead and group the first two. From the first two, I could factor out just x. That leaves me with 5x minus 3. From the last two, I could factor out negative 3, which leaves me with 5x minus 3. Then I can factor out 5x minus 3 from both, and that leaves me with x minus 3. From here, we have two things that are multiplying together and they equal 0. So either the first thing can equal 0, then 0 times this will equal 0, and that'll be a solution. Or the second thing could equal 0, and then, of course, 0 times this will give me 0. So the two solutions are 3/5 and 3. Oops. All right, moving on to part B. On part B, now you might be inclined to go ahead and simplify this, but don't do that, right? If it's in vertex form like this, then it's easy, just subtract the constant. So subtract 6 on both sides, so I have 1/4 times 2x plus 3, squared equals 6. Then I can go ahead and multiply 4 to get rid of that coefficient, right? So now I have 2x plus 3 squared equals 24. And then I want to get rid of the squared, okay? So to get rid of the squared, now that this is something squared by itself, I can square root both sides to get rid of that squared. Remember, when you square root both sides, you get plus minus. And 24 can actually simplify. 24 is 4 times 6. So 4 is a perfect square, and a 2 will come out of that radical. So this simplifies to 2 square root of 6. On the left side, since the square cancels, we just get 2x plus 3. And then to solve for x, the last few steps would be to subtract 3 on both sides. So we have 2x equals negative 3 plus minus 2 square root of 6. And then divide 2. So my final answer is x equals negative 3 plus minus 2 square root of 6 all over 2. Okay. Let's go ahead and move on to number 3. So on number 3, it says a rectangle has an area of this quantity, and the width is, what is the width is the question, if the length is this much. So there's two ways to do this. The area of a rectangle is length times width. So if I could write this expression as something times something else, one of those something is the length and the other one is the width, right? The other thing that you could do to solve for the width, right, since area is length times width, then width is area divided by length. So you have the length and you have the area. You could do x squared plus 13x plus 36 divided by x plus 9 in order to find the width. I'm not going to do it that way because I think factoring is easier. Okay, so I'm going to write the area, that is x squared plus 13x plus 36. I'm going to factor this so I have something times something else. Now, multiplies to 36 and adds to 13 is 4 and 9. So this will factor into x plus 4 times x plus 9. Much, much easier. So they already told us that the length was the x plus 9. So guess what the width is? X plus 4. Okay. And then let's go ahead and do number 4. So on number 4, a square has an area of this much square meters. What is the side length of the square? Okay. Well, notice here that this is a square, right? And a square is, the area of a square is still length times width, but the length and the width are the same length. So it's really the same number, right? So that number here will be the same. If the side length is the same. So when I did the one before, right? This was a rectangle, so the width and the length were two different expressions. Here, because this is a square, the width and the length will be the same expression. So let me show you what that looks like. If we try to factor this, notice that this is a perfect square trinomial, right? The first term squared would be 8 squared. The last term squared would be x squared. And then in the middle, if you check, right, -2 times the a value, 8, times the b value, x, that checks out. -2 times 8 times x is -16x, right? So I'm using the identity, a squared minus 2ab plus b squared, and that factors into a minus b all squared. So because this does check out, right, to this identity, then I can factor this into a, which is 8, minus b, which is x, all squared. So from here, right, this is the area. And the reason why it's squared is because it is 2 copies of that side length multiplied together. One of these side lengths is length, one of them is the width, right? But they're both the same side length because this is a square. So what is the side length of the square? The side length is 8 minus x. Okay. Let's go ahead and move on to number 5. So on number 5, we're finding the zeros. Remember that zeros, solutions, x-intercept, and roots all mean the same thing. They're all referencing to set f of x equal to 0, the output equal to 0. So to find the zeros, I would set this output to equal 0. So I have 9n squared minus 4. Actually, I need to write minus 7n first. Remember, we want it in standard form. So highest exponent to lowest exponent. And then we're going to set that f of n to equal 0. That way the output equals 0. And I actually find the 0 of the equation. So now, the first term is a perfect square, and the last term is a perfect square. However, right, if you write the first term as a perfect square, it will be 3n squared, and the last term as a perfect square will be 2 squared. The middle, -2 times 3n times 2, does not equal this middle term, 7n. So I cannot use this strategy to factor. This is not a perfect square trinomial. And even at that, if I try to rainbow over, right, multiplies to -36 and adds to -7, if I go through all of the things that multiply to -36, none of them will add up to -7. So I can't use factoring either. So if you can't use an identity and you can't factor, well, what do we got remaining? Quadratic formula. Remember the quadratic formula, x equals -b. Plus minus the square root of b squared minus 4ac all over 2a. And here the a, b, and c values are referencing to the quadratic formula. A is the coefficient of the quadratic term. B is the coefficient of the linear term. And c is the coefficient of the constant term. So here a is 9, b is -7. And c is -4. So those are your a, b, c values that you would plug into here. Now, the variable for this question is not actually x, it's n. So I should really write n equals, and then -b, -7 is +7, plus minus the square root of b, -7 squared, minus 4 times a, which is 9, times c, which is -4. And this is all over 2 times the a value, a is 9. Now we're going to simplify by terms. Simplify this term, simplify this term, simplify the bottom term. So we have 7 plus minus. Now -7 squared is +49. -4 times -9 is -36. -36 times -4 is +144. And in the denominator, 2 times 9 is 18. Now that we have each term simplified, we can go ahead and actually combine and add 49 and 144 together. 49 plus 144 is 163. So this answer is 7 plus minus the square root of 193, all over 18. Now, 193, if you try to simplify that, right, if you try to simplify that radical, there is nothing that you have two copies of, so it does not simplify any further, and that is your final answer. All right, for part B, we're still finding zeros here, right? So we still need to set the output to equal 0 to solve for this. Now this one is x squared minus 2x minus 24, and I could try to factor, right? The coefficient is 1, so this should be easy factoring. Multiplies to negative 24 and adds to negative 2. Multiplies to negative 24 and adds to negative 2, 4 and 6, right? We just want to make sure the 4 is positive and the 6 is negative. That way we add to a negative 2 instead of adding to a positive 2. So this will factor into x plus 4 times x minus 6. And so therefore x plus 4 could equal 0, which gives us a solution x equals negative 4. And then x minus 6 could equal 0, which gives us a solution of positive 6. Okay, let's move on to number 6. On number 6, we're finding the roots, right? So that means that we are finding the zeros, we're finding the x-intercepts, we're finding the solutions. Remember, solutions, x-intercept, roots, zeros, these are all talking about the same thing. So again, we are setting f of b, the output to equal 0, and we are trying to solve this one. Now on this one, the first term and the last term are both perfect squares. So I'm thinking maybe this is a perfect square trinomial. Let's go ahead and try it. Over here it didn't work out, right? Let's try it over here. So the first term will be 4b all squared. The last term would be 5 squared. And in the middle we have to check. Does negative 2 times 4b times 5, does that equal negative 40b? And in this case, it does. Okay, it does actually check out. So this is a perfect square trinomial, and therefore I could factor it into a, which is 4b, minus, because the middle term's negative, b, which is 5, all squared. So now to solve this one, we're going to go ahead and square root both sides. Now when we square root both sides, remember we do get plus minus, but we're getting plus minus 0, right? Which adding 0 and subtracting 0 will end up being the same thing. So that's silly to write. Let me just go ahead and erase it. I wanted to put it there just so you know if it's any number other than 0, then you have two answers. Then I'll go ahead and add 5 to both sides and then divide 4. So we have our solution is 5/4. Only one solution on that one, because it was the square root of 0, right? All right. On part B, I'm going to go ahead and set h of x to equal 0, right? And then I'm going to go ahead and solve by factoring, trying to factor first. If not, then I use the quadratic formula. Now this one is actually, both of these are perfect squares, right? And actually, let me take that back a second. I could solve this by factoring, but there is no x term, right? There's no linear term. So it's actually really much easier to solve this one. If we subtract the constant, 81, we get negative 81 equals 4x squared. And then we can divide 4 on both sides. So we have negative 81 over 4. And then the x squared is by itself now, so all I have to do is square root both sides. Remember, when we square root both sides, the result is plus minus, right? If it's plus minus 0, then positive 0 versus negative 0, 0 is neutral, so it doesn't matter. But any other number, that plus minus really matters. So the square root of negative 81 would be 9i, and then over the square root of 4, which is 2. So our solution is positive negative 9i over 2. You could solve it by factoring, but it is easier to just take the square root. Okay, moving on from there, let's go ahead and do number 7. So on number 7, it says that a sky tower in New Zealand is the tallest man-made structure in the southern hemisphere. And it has a height of 328 meters, okay? One of the popular tourist attractions is to jump off of the tower or to walk outside of the observation deck. On vacation, Sydney was walking on the outside and threw an apple, and it had the initial velocity of 40 miles per hour or 17.882 meters, okay? So you have to remember that a object that is a free-falling object, right, where we ignore air resistance, a free-falling object can follow the model h of t equals at squared plus bt plus c. Now, for this model, right, h of t represents the height at time t. A is the gravity coefficient, and remember we use -16 if we are referencing feet, -4.9 if our unit of measure is meters. The B coefficient, the coefficient of the linear term, is actually the initial velocity, and then C, the constant term, is the initial height. Okay, so with that being said, right, now we can make an equation to represent this problem, right? The equation to represent this problem would be h of t equals, the gravity coefficient would be -4.9. Why am I using -4.9 instead of -16? Because the problem unit of measure is meters, okay? So I am going to use -4.9. And then the initial velocity is given to us right in the problem. They give us 40 miles per hour, but we don't want miles, right? The unit of measure needs to be meters. So we're going to use 17.882 for that. And then C, the initial height, was also given to us right in the question, which is 328. So this is the equation that models this problem. Now, let's go ahead and do part A. Okay, part A says how many seconds will it take for an apple to hit the ground, okay? Hit the ground means that we have a height of what? The height at the ground is a height of 0. So we need this h of t, this height, to be 0. So we're solving for t when h of t is 0. Oops, I forgot to square it on this model equation that I wrote. Okay, so we're solving for the height of 0. What time t will equal a height of 0? There's decimals on here, so we definitely need to use the quadratic formula, all right? So on this one, we have t equals -b. B in this case is 17.882. Now in the question, they did say that I could round to the nearest tenth, so I'm just going to go ahead and round to the nearest tenth right at the beginning. So -17.9. plus minus the square root of that b, 17.9 squared, minus 4 times the a value, which is -4.9, times the c value, which is 328. Let me go ahead and extend my radical bar there. And then that's all over 2 times the a value, which the a value is -4.9. Okay. So now let's go ahead and simplify in parts, okay? So I'm going to bring over the -17.9 plus minus. Here we go. Now 17.9 squared, if you round it to the nearest tenth, is 320.4, okay? And the -4 times -4.9 times 328, if you round it to the nearest tenth, is positive, so plus 6,428.8. Then the denominator, 2 times -4.9, is -9.8. Continuing now, we need to simplify and add these two numbers together. So 320.4 plus 6428.8 is, I'm not sure. Let's go ahead and do that. 320.4 plus 6428 not 0.6, let me delete that, 0.8 equals 6749.2. And then if I take the square root of that answer that I had, I get about 82.2 if we round to the nearest tenth. So we have the square root of 6749.2 But then when we take the square root of that and we round to the nearest tenth, we get, it's roughly about 82.2. Okay, so we have two numbers here, two answers, right? Negative 17.9 plus 82.2 divided by negative 9.8. And we have negative 17.9 minus 82.2 divided by negative 9.8. So rounding both of these, okay, estimating both to the nearest tenth. For the first one, if we add 82.2, we get negative 6.6. And then for the second one, if we subtract 82.2, we get 10.2. Now, what does t represent? T is the time that it takes to reach a certain height, h. So can t time be negative? No. So our final answer will be 10.2, and this unit of measure for time is seconds. All right. So now we're going to go ahead and do part B for this one. So part B is just asking for the same, basically the same question, but just a different height. So here they're asking how long will it take to reach a height of 85 meters. So instead of the height h of t being 0, because 0 is where it hits the ground, the height at the ground is 0. Here we want the height to equal 85, and we're trying to find what time t equals a height of 85. So now we have the equation 85 equals negative 4.9 t squared plus 17 point, I'm just going to go ahead and put 0.9 because we're running to the nearest tenth anyway. I'm going to continue that. And then plus 328. So now here's the thing. Your A, B, and C are not negative 4.9, 17.9, and 328. A and B are the same, but C is going to change because I need to subtract 85 on both sides. Remember, you need equals 0, right, to use the quadratic formula. So yes, A is the same, and B is the same. Oops. But C is 328 minus 85, which in this case would be 243. Okay, so I'm going to go ahead and use the quadratic formula now. So we have time t equals negative b, so still negative 17.9 plus minus the square root of b squared, which b squared is still going to be 320.4. But then we have negative 4 times a, and then c is different, 243. So that's going to change the second term here, okay? And this is all going over 2 times a, 2 times negative 4.9 is still going to be negative 9.8. So the difference is here, negative 4 times negative 4.9 times 243 is actually 4762.8. So we're adding 4762.8 to the 320.4. I'm just going to bring down the rest of the equation over. And then when we add 320.4 plus 4762.8 and we square root it, we get roughly around, rounded to the nearest 10, 71.3. So now we have two answers, right? We have negative 17.9 plus 71.3 divided by negative 9.8, and we have negative 17.9 minus 71.3 divided by negative 9.8. The adding gives us negative 5.4, subtracting 71.3 gives us positive 9.1. And again, t represents time. You can't take a negative amount of time to reach there. So our answer, it takes 9.1 seconds. And that is it. All right, let's move on to the next question. So number 8, an arrow was tossed in the air with an initial velocity of 15 inches per second from a height of 5 feet. Okay, I already see an issue. The velocity is in inches, okay, and the height is in feet, okay? 15 inches per second. So if you want to change that to feet per second, how do you convert inches to feet? Well, if I had 12 inches, what I would do to convert that to feet is I would divide by 12, and that would give me 12 inches equals 1 foot. So if we have 15 inches, we're going to divide by 12, and we get 1.25 feet, okay? Now, the question says to just write an equation for representing the arrow's height. So we're using that same h of t equals gravity. Here we're using feet, so we're going to use -16. Plus the initial velocity, which is 1.25, plus the initial height, which is 5. And that's the equation. Okay, let's move right along. So moving on to number 9, it says consider the graph that represents the projectile fired of a water balloon launcher from the roof of a 10-story hotel. It took the water balloon how many seconds to reach maximum height? So maximum height, you see here, we started here, right? And then our max height is right here, which is about like a little less than 200. Luckily for us, there is a point here, so we can see that it is not, we don't even have to approximate. We know that it is exactly, that it is exactly a height of 196.6. Now the first question here, it says, how long did it take? How many seconds? So the amount of seconds is actually the x value, which is the time, which would be 2.2 seconds, okay? Now the water balloon was actually fired at the start, right? At 0 time at the start, the initial start, it was fired at a height of 120 feet, okay? And then the water balloon takes approximately how many seconds to hit the ground? Hitting the ground is a height of 0, right? So we went up and then we came back down, a height of 0. It took us 5.7 seconds. And then lastly, the maximum height of the water balloon will be the y value here, right? This is the height, which is 196.6. Okay. Number 10, let's go ahead and simplify each of the following here. So on this one, the issue is that you cannot have a radical in the denominator, right? So I'm going to go ahead and multiply by the square root of 7 over the square root of 7. Square root of 7 times the square root of 7 is the square root of 49, which is just 7. And then 8 times 7 is 56. So we get the square root of 56 at the top. Now the kicker is that 56 can be broken up, right? 56 can be broken up into 2 times 28, and 28 can be broken up into 2 times 14, and then 14 is 2 times 7. So a 2 comes out of the radical, and a 14, because the 2 times 7 don't have pairs, the 2 times 7, 14 stays on the inside of the radical. So this simplifies 2 times the square root of 14 all over 7. Okay, for part B, here, this is the cube root, right? So we have the cube root of 24, so we need 3 copies, not 2 copies. Here we only need 2 copies. This is the square root, right? Imaginary 2 right there. But we need 3 copies. So 24 breaks up into 2 times 12. 12 breaks up into 2 times 6. 6 breaks up into 2 times 3. So we actually have 3 copies of 2, so a 2 will come out. There's already a 3 there, so I'm going to leave it there. A 2 will come out of this cube root, and then a 3 will stay on the inside of the cube root. So we have 3 times 2, which is 6, so this simplifies into 6 cube root of 3. For part C, on this one we have a cube root of 3 over cube root of 6. Now, this is the cube root of 6. So if I multiply by another cube root of 6, is going to be the cube root of 36. The cube root of 36 is not a perfect cube, okay? So just be careful with that. The other thing that I want to point out is that 3/6 can actually be simplified before you break up the radical, right? So it's actually better, it takes less time to simplify the fraction first into 1/2 The cube root of 1 is 1, and then the cube root of 2, now we have a smaller number to work with. Again, if I just multiply by one copy of the cube root of 2, that's not going to work because that's the cube root of 4, and 4 is not a perfect cube. I have to multiply by the cube root of 2 squared. That way I'm multiplying by the cube root of 4. 4 times 2 is 8, and the cube root of 8 is 2. So my final answer would be cube root of 4 over 2. All right, and then the last one, part D. Here we have the square root of 72 that we're trying to simplify. Now 72 can be broken up into 2 times 36, and 36 actually is 6 times 6. So there's a 6 that will come out of this square root. Remember, it's a square root, so you only need 2 copies for that number to come out. And then the square root of a 2 remains on the inside. Okie dokie, let's move on to number 11. So for number 11, we are simplifying each of these. And on the first one, we have I to the power 31. Remember that i's to any power will only equal one of 4 things. Either 1, I, -1, or -I. And it just rotates between all 4 of these. If you wanted to count and you wanted to say, okay, this is 3, then it rotates back. I to the power 4, I to the power 5, I to the power 6, I to the power 7, I to the power 8, I to the power 9, I to the power 10, I to the power 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, so we landed here. It's I to the power -1. I'm sorry, I to the power 3, which equals -I. Right, so this equals -I. But that, I mean, is silly to go through, and you could actually accidentally make a silly mistake. So what we covered in class is just divide by 4, right, and look at the reciprocal. So 4 goes into 31 7 whole times, and you get 3 as a remainder. So the remainder is where you left off at, and so I to the power 31 is equivalent to I to the power 3, which is equivalent to -I. Okay? Your i's cannot have any powers. You have to simplify them. Even I to the power 2, you can't leave it like that. It's -1. If your I has any power whatsoever, you have to simplify that. Okay? Let's go ahead and do part D. So here we're simplifying the square root of -98. Now -98 can be broken up into -1 times 98. That way the square root of -1 is just going to give me I. And 98 can be broken up. 98 is 2 times 49, and 49 is actually 7 times 7. So a 7 will come out of that. So the square root of -1 gives us the I. A 7 comes out of the radical, and then a 2 stays on the inside of the radical. All right, for part B, here we have 2 binomials multiplied together. So let's just go through and distribute each term one at a time. -1 times -1 is 1. -1 times I is -I. -3i times -1 is +3i. -3i times +I would be -3i squared. Now, I squared is -1. So this is actually -3 times -1, which is +3. So we have 1 plus 3, which is 4, and then -I plus 3i, which is 2i. Okay, moving on to part C. So on part C, we're actually adding this term and this term together, but before I add that, I'm going to go ahead and distribute 2i here. There's nothing to distribute here in the front, so I could just bring that outside of the parentheses. But here I do need to distribute 2i. 2i times 3i is 6i squared. 2i times 7 is 14i. Now, I can go ahead and combine 2i squared plus 6i squared is 8i squared. So we have 21 plus 8i squared plus 14i. Now you cannot leave it like that because remember, anytime I has a power, you have to simplify it. I squared is -1, so this is 8 times -1. So this is 21 minus 8. Positive 8 times -1 will be -8, so it's 21 minus 8. And 21 minus 8 is 13. So this is 13 plus 14i. Okay, moving on to part E. On part E, we kind of have the same similar, well, I shouldn't say the same, but similar to what we just did on part C. We have a coefficient here that we need to distribute before we can bring that out of parentheses, and there's a -1 here that we need to distribute before we bring that out of parentheses. So 30 times -7 is -210, and then I times I, of course, I squared. Then 30i times -1 will be -30i, and then -1 times 8 will be -8, -1 times -10 is +10i. Then we can go ahead and combine like terms and also replace I squared with -1. So this is -210 times -1, which is +210. So we have 210 minus 8, which would be 202. And then -30i plus 10i, which would be -20i. Okie dokie. Last one, part F. So on part F, we have a fraction here. And the issue is that you cannot have a radical in the denominator. I is a radical. Remember, I is the square root of -1. So because of that, you cannot have I in the denominator. So remember, to get rid of a complex number, you need to multiply by the complex conjugate. So I'm going to multiply by the same exact binomial as the denominator, but the I term changes sign. So negative. I'm going to multiply by -3 minus 2i. And of course, this is a fraction, so whatever I do to the bottom, I have to do to the top to keep it equivalent. So I'm multiplying these two together. Let's go ahead and distribute both. So I have 6 times -3 is -18. 6 times -2i is -12i. I times -3 is +3i. I times -2i is +2i squared. In the denominator, we need to distribute here as well. -3 times -3 is 9. -3 times -2i is 6i. 2i times -3 is -6i, and 2i times -2i, +2 times -2 is -4, I times I is I squared. Now we have to simplify. I squared is -1, so this is really 2 times -1, which is -2. -18 minus 2 is -20. And then -12i plus 3i will be -9i. In the denominator, notice that the 6i minus 6i would cancel. I squared is still -1, so this is -4 times -1, which is +4. 9 plus 4, 13. Now there are no i's in the denominator, and we're all good. Okie dokie. Let's move on to number 12. So for number 12, we need to go ahead and explain how to determine the number and type of solutions for a quadratic function, right? Without actually finding the solution. Of course, we can find the number and type of solutions if we find the solution, but without finding it, what we can use is use the discriminant. Remember, the discriminant is b squared minus 4ac. It's what's under the radical of the quadratic, right? So this a, b, and c are referencing the standard form of the quadratic function, right? A, b, and c from the coefficients and the constant c of the quadratic function. If that discriminant, let's call it d. If the discriminant is a number that is positive, right, then you're taking the square root of a positive, which would be 2 real solutions. If the discriminant is exactly 0, then you end up adding and subtracting, right? Because remember, in the quadratic formula, you do plus minus the square root of the discriminant, b squared minus 4ac. So then you'll be adding and subtracting 0, which would give you 2 repeated solutions, which would end up really looking as only 1 real solution because the solution is repeated. Here, if it is positive, if the discriminant is positive, the 2 real solutions are 2 distinct. They're different numbers. They're not the same solution. And then lastly, if the discriminant is negative, then you have no real solutions, which basically means you have 2 imaginary solutions. And that's how you would figure it out. All right, for number 13, let's go ahead and solve by U-substitution. Okay, for part A, this is much easier because what is inside the parentheses is what U equals. We need to figure out what U equals first so that then we can replace that thing with U. So U in this case would be what we see repeated here, which is the 2x minus 1. So now that U equals 2x minus 1, I can replace, instead of writing 2x minus 1, U squared minus U minus 12 equals 0. Now, I can factor this to solve for U, right? The coefficient here is 1. So multiplies to negative 12 and adds to negative 1 would be negative 4 and 3. So this will factor into U minus 4 times U plus 3. Let's be a little careful with our U's here. They're starting to look like 4s. Let me curve them a little bit. Okay. So if U minus 4 equals 0, we get the solution of U equals 4. And if U plus 3 equals 0, then we get the solution of U equals negative 3. Now, of course, this is not our final answer because that is what U equals. The original equation was asking us for x. So let's replace U with x. So you have 2x minus 1 equals 4, and 2x minus 1 equals negative 3. So if we add 1 here, we get 2x equals 5, and then divide 2, we get the solution x equals 5 over 2. And then over here, if we add 1, we get 2x equals negative 2. And then when we divide 2, we get the solution x equals negative 1. So these are our two solutions for x. All right, let's move on to part B. So on part B, I'm also using U-substitution here, right? But this one's a little bit different. I have to find what does U actually equal. And remember, it's easy. It's just the square root of this first term. So U equals 2x squared. So I'm going to go ahead and write the first term as something squared, and the middle term I need to write it as something times that same U value, okay? So this would be 2x squared squared, right, equals 4x squared. And then what times 2x squared will give me negative 12x squared? Well, negative 6 times 2x squared will be give me negative 12x squared. The 7, the constant, we just bring that down, right? And then now that we have it written like this, you see how it was already like that on this one? And so that was U. Now that we have it written like that, we can replace that with U. So we have U squared minus 6U minus 7 equals 0. So the coefficient is 1. This is easy factoring. Multiplies to negative 7, adds to negative 6. We would have multiplies to negative 7, adds to negative 6, negative 7 times 1, negative 7 plus 1. So this factors into U plus 1 times U minus 7. So U plus 1 equals 0 will give us the solution U equals negative 1. U minus 7 equals 0 will give us the solution U equals 7. We are not trying to solve for U. We're trying to solve for x. So now we have to take U and replace it back with 2x squared. So 2x squared equals 7. And then we go ahead and we solve. Let's go ahead and divide 2 on both sides here. We get x squared equals negative 1 over 2. And then we're going to go ahead and square root both sides. Remember, when you square root both sides, your result is plus minus. The square root of negative 1 is just I. And then on the denominator, square root of 2. Now we can't have a radical in the denominator, so I'm going to go ahead and multiply by square root of 2 over square root of 2 to get rid of that radical in the denominator. So we have two answers here, positive I square root of 2 over 2 and negative I square root of 2 over 2. Over here, we're going to get two more answers. Let's go ahead and divide by 2 on both sides. So I have x squared equals 7 over 2. And then we'll go ahead and we square root both sides. So we got x equals square root of 7 over square root of 2. But we can't have a radical in the denominator, so I'm going to multiply by square root of 2 over square root of 2. So we get, oops, I almost forgot, square root of both sides, plus minus. I almost forgot to write that down, right? X equals plus minus. Square root of 7 times 2 is 14 over 2. So I ended up with 4 answers on this one. All right, let's move on to 14. Okay, so on number 14, we need to complete the square. So for part A, remember for completing the square, we need to separate the first two terms from the back term. And then when the coefficient is 1, and only when the coefficient is 1 here, b over 2 squared to find what we need to add here in order to complete the square so that this it becomes a perfect square trinomial. So our b value is 40. If we divide it by 2 and then we square it, that would be 20 squared, which would be 400. So we need to add 400 here to make this a perfect square trinomial. Now, of course, we can't just add something to an expression and expect it to be equal, right? So we actually need to add 0. So instead of adding 400 by itself, I add 400 here and then subtract 400 on the back. So essentially, I'm doing nothing. So now this is a perfect square trinomial, so it will factor, right, into a binomial squared. A is x, b is the square root of 400, which is 20. And then on the back, 3 minus 400 is negative 397. And there we go. All right, for part B, same thing. We're going to go ahead and split the first two terms from the last term. However, here, the coefficient is not 1. You can only use this formula to find what to add here when A is 1. So we have to factor out whatever value is there on A. So I'm going to go ahead and factor out 4. Only factor out from the first two, because remember, the last term, you have that separated. You do not want to mess with that at all. You do not want to factor that at all. Don't do anything with that until the end, where you just simplify it. So this would be x squared minus 4x. Now when the coefficient is 1, our b value is negative 4. We're going to take that, we're going to divide it by 2 and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we're going to go ahead and add 4 here. And then, like before, what did we do? We subtracted 4 on the back, right? But this is not 4. It's 4 times 4. It's actually 16. So we have to subtract 16 on the back. So this is 4 times, this would be x minus 2 squared, right? If we factor that trinomial. And then 49 minus 16 is 33. Moving on to number 15. For number 15, we have x squared plus 7x minus 49 equals 0. So we need to solve by completing the square is what they want us to do. So I'm going to go ahead and split the first two terms from the last term. And then I'm going to take the coefficient is 1, so I'm going to take the b value, which is 7, divided by 2, and square it. So 7 over 2 squared would be 49 over 4. So I'm going to add 49 over 4, and then I need to subtract 49 over 4 on the back. Because there was no coefficient here, if I multiply, right, that's 49 over 4 times 1, which is a 49 over 4. So now I'm going to go ahead and factor this, right? It's a perfect square trinomial, so it actually factors to x plus 7 over 2 squared. 7 over 2 plus 7 over 2 is 7. 7 over 2 times 7 over 2 is 49 over 4. And then negative 49 minus 49 over 4, if you simplify that, is negative 245 over 4. Okay, that's just fraction operations there. Now, that's completing the square. Now let's do the solving part, right? To solve, I'm going to go ahead and add 245 over 4 on both sides. So I get x plus 7 over 2 squared equals 245 over 4. Now that the square is by itself, I can go ahead and square root both sides to get rid of that square. Remember, when you square root both sides, your result is plus minus. So we have x plus 7 over 2 equals plus minus square root of 245 over the square root of 4, which is 2. Now the square root of 245, I can actually simplify that. 245 is 5 times 49, and 49 is 7 times 7. So there's a 7 that comes out of that. So I'm just going to erase it to simplify it. And then a square root of 5 that stays on the inside. Okay. The last step would be to subtract 7 over 2 on both sides. And so our final answer, x equals, usually the constant goes in the front, and then your plus minus radical goes in the back. And that's my final answer. Okay, for number 16, we need to find the vertex form. Okay, to find the vertex form, all you have to do is complete the square. Okay, because when you complete the square, you're going to get it to look like vertex form. Remember, the vertex form is y equals a times x minus h squared plus k, right? So you have binomial squared, some coefficient, something adding to the back, right? That coefficient could be 1, the adding to the back could be 0. So it could just be a binomial square. So all we have to do to get the vertex form is complete the square, okay? So let's go ahead and do that. Separate the first two terms from the last, right? The coefficient is 1, so take your b value divided by 2 and square it. So it'll be 10 squared, which is 100. So splitting up the first two terms from the last term, we need to then go ahead and add 100 to the inside here to get this to be a perfect square trinomial, and then we're going to subtract 100 on the back because the coefficient here is 1, so this is 100 times 1, which is 100. And then x squared plus 20x plus 100 would factor into x plus 10 squared. 10 times 10, 100. 10 plus 10, 20. And then negative 86 minus 100 is negative 186. And so now you could see this looks like the vertex form. A is 1, and that's h would be negative 10. K would be negative 186. All right, let's move on to number 17. So on 17, we just need a factor here, okay? Now there are two terms here, and I can factor out a GCF of 3r cubed. So I'm going to go ahead and factor out 3r cubed. If I divide 48r to the power of 5 divided by 3r cubed, I would get 16r squared. And then negative 243 divided by 3 would be negative 81. Now, once I do that, once I factor out a GCF, notice that this is the difference of squares, right? So this will factor A from the difference of squares would be 4r, and then B from the difference of squares would be 9. So the difference of squares, remember, a squared minus b squared factors, oops, I wrote a squared because I was saying, a squared minus b squared factors into a plus b times a minus b. So this is a, this is b, so this will factor into a plus b times a minus b. Now, I know you might be inclined to think, oh, well, 4 is a perfect square, 9 is a perfect square. So isn't this the sum of squares, and isn't this the difference of squares? Can't we continue and keep going and go again like is similar on number 1, right? Well, both of these were perfect squares. It was b to the power of 2. Here you just have r. It's not r to the power of 2. So the entire term is not a perfect square. So you're done. All right, number 18, perfect square trinomial, ax squared plus bx plus c is equivalent to this right here. So what is the value of a minus b plus c? Okay, so they're just saying that there's a trinomial, it equals this, so coefficient a, b, c, what are they? Subtract a and b, and then add c. That's it. So let's go ahead and do 2 copies of this, multiply together. 1.2x minus 0.7 times 1.2x minus 0.7. 2 copies of that, multiply together. 1.2x times 1.2x is 1.44x squared. 1.2x times negative 0.7 is negative 0.84x. Negative 0.7 times negative 1.2 is negative 0.84x again. And then negative 0.7 times negative 0.7 is positive 0.49. So now all we have to do is combine this middle 2 terms, right? So we get 1.44x squared minus 1.68x plus 0.49. So your A value is 1.44, okay? Your B value is negative 1.68, and your C value is 0.14, okay? So now we have to do A minus B plus C. So A, which is 1.44, plus, minus B. So it would be minus a negative 1.68, and then plus C, which is positive 0.49. Now 1 minus a negative is really a plus, so it's 1.44 plus 1.68 plus 0.49. And if we add all of those up together, we end up with 3.61. All right. Let's move on to number 19. So number 19, we're solving for x, okay? In terms of y, just means that y will be on the other side of the equation, okay? So we're solving for x. Okay, I'm gonna go ahead and try to solve by factoring, right? So this first term here is a perfect square, and the last term is also a perfect square. So maybe this is a perfect square trinomial. Let's write the first term as a perfect square will be 7x all squared. The last term as a perfect square will be 10y all squared. In the middle, it should check out, is negative 2 times 7x times 10y, is that equal to negative 140xy? Yes, it is. So this will factor into a minus, because the middle term is negative, b all squared. Now we are trying to solve for x, so I'm going to go ahead and square root both sides. Okay. Now we do get plus minus 0, but 0 is neutral, so it's just going to be 0. And then we're solving for x, so that means I need to add 10y to both sides and then divide 7. And that's all she wrote. All right, let's move on to number 20. So on number 20, we have a square poster that has an area that measures this much. What is the perimeter? Ooh, okay. Well, before we find the perimeter of a square, okay, if it's a square, the perimeter is all the sides added up. All the sides are the same length, so the perimeter of a square is just 4 times the side length. We can call the side length L. You can call the side length whatever you want. Okay, it's just 4 times L because it's 4 sides added up together, but the 4 sides are all the same. The first thing we need to figure out is what is that side length. Okay, so I'm going to go ahead and factor this one. The first and the last term are perfect squares. 324 is 18 squared. And then 225 is 15 squared. The middle should check out. 2 times 18x times 15 is 540. And the reason why I assumed it would check out is because this is a square, so I know it is a square, so I'm expecting it to be a perfect square already. So now that we have it like this, right, the a value is 18x, the b value is 15. So this will factor into a, and the middle term is plus, so plus b, which is 15, all squared. So that means that the side length of the square is 18x plus 15, right? Because the area is side length squared, so the side length is 18x plus 15. Now, the side length is 18x plus 15. That is not the answer. We are looking for the perimeter, okay? For the perimeter is 4 times the side length. So the perimeter would be 4 times 18x plus 15, which in this case would be 72x plus 60. All right. Moving along to 21. So on 21, I need to factor every single one of these. Okay, remember the first thing that we do to factor is see, can we factor out a GCF? I could factor out 3 from all of these. I could also factor out x from all of these. So I'm going to factor out 3x. which leaves me with x plus 6y. Oh, no, 6 divided by 3 is 2, plus 3y squared. Now we have a trinomial, right? And we can try to factor this. Multiplies to 3, adds to 2. Is there anything? No. So that's as much as we can factor this one. We are done. Let's move on to part B. So on part B, again, we can factor out a GCF of 2. We can't factor out an x from all these because the last term doesn't have an x. So we can factor out 2, which leaves us with x squared plus 7xy minus 18y squared. Okay, so now we need to multiply to negative 18 and add to 7. So it'll be 9 times negative 2, 9 plus negative 2. So I'm going to go ahead and write this out. X, bring down the first term, x squared, bring down the last term, negative 18y squared, and then break up the middle, positive 9xy minus 2xy. Grouping the first two, we could factor out x, which leaves us with x plus 9y. Grouping the last two, we could factor out negative 2, which leaves us with x plus 9y. And then we could factor out the x plus 9y, and leaves us with x minus 2. All right, moving on to part C. On part C, we need to multiply to 44 and add to 15. Pretty easy. 4 times 11 is 44. 4 plus 11 is 15. And remember, when the coefficient is 1, you do not need to break up the middle. If the coefficient is 1 and it's simple, it's just one variable, no need to break up the middle. This will factor into x plus 4 times x plus 11. Okay, back up on part D. Multiplies to negative 28, adds to negative 4. Okay, 28 divided by 1 is 28. Negative 28 plus 1 would not be negative 4. 28 divided by 2 is 14. Negative 14 plus 2 is not negative 4. 28 divided by 3, 3 is not a factor. 28 divided by 4. Okay, 4 plus negative 7 is not negative 4. 28 divided by 5, 5 is not a factor. 28 divided by 6, 6 is not a factor. And I get a result that is smaller than what I initially divided by. So guess what? This one does not factor. It is considered prime, not factorable. All right, moving on to part E. On part E, we could factor out a GCF of 3, which gives us 6b squared plus 5b minus 4. Now that we factored out the 3, we can go ahead and rainbow over because there is a coefficient here. So we're going to rainbow over, multiplies to negative 24, and adds to 5. Okay, multiplies to negative 24, adds to 5. We have 8 times negative 3, 8 plus negative 3. So because the coefficient is not 1, we can't just, write the two numbers here like this. The coefficient is not 1, so we need to break up the middle. Bring down the first term, bring down the back term, break up the middle, 5b into 8b minus 3b. You could write negative 3b plus 8b. That's fine as well. Now we need to group the first two, factor out as much as we can. We could factor out a 2, we could factor out a b. So we're going to factor out 2b. That leaves us with 3b plus 4. And then on the last two, we can't really factor out anything other than we are going to factor out a negative 1. That way the 3b will be positive 3b and the 4 will be positive 4. That way it can match with this one. Remember, these two have to be exactly the same, so then we can factor those out, 3b plus 4, and then that leaves us with 2b minus 1. All right, and then last part, part F. On part F, we are going to factor here. We can't factor out a GCF, so just rainbow over, multiplies to 20, adds to negative 21. So that'll be negative 1 times negative 20, negative 1 plus negative 20. And again, if the coefficient is not 1, then you have to break up the middle, bring down the first term, bring down the last term. You can't just write it easy like this, okay? So we're going to bring down that first term, bring down the back term, break up negative 21 into negative 1k minus 40k, not 40, minus 20k, excuse me. And then we're going to group the first two. We can factor out k from the first two, which leaves us with 4k minus 1. And then grouping from the last two, we can factor out negative 5, which gives us 4k minus 1. Now the 4k minus 1 is the same on both, so I could factor out 4k minus 1, and that leaves us with k minus 5. All right, and that's factoring. So let's move on to number 22. All right, on number 22, we need to solve by U-substitution. Remember for U-substitution, you want to look at that first term, square root it, right? So U is 5x squared. So I'm going to go ahead and replace that. U is 5x squared. So the first term would be U squared. And then the middle term, what times 5x squared equals negative 10? Well, negative 2 times 5x squared equals negative 10. The constant we just bring down. Now that we have that in there, we can replace u back. U squared minus 2u minus 3 equals 0. And then we could solve for u from here. We could solve by factoring. This is easy factoring. Multiplies to negative 3, adds to 2, would be negative 3 and 1. Right? Negative 3 times 1, negative 3 plus 1. So u minus 3 equals 0 will give us the solution u equals positive 3. And then u plus 1 equals 0 will give us the solution u equals negative 1. We need to replace u back with what u equals, which is 5x squared. So 5x squared equals negative 3. Positive 3. And then 5x squared equals negative 1. Then we solve, divide 5 on both sides, so we have x squared equals 3/5. And then square root both sides. Remember, when we square root both sides, the result is plus minus. And we can't have a square root in the denominator, so I'm going to go ahead and multiply by square root of 5 over square root of 5. So I end up with the solution plus minus square root of 15 over 5. That's two solutions right there. I'm going to go ahead and divide 5 on this side as well. So we have x squared equals negative 1/5. And then we square root both sides. Remember, when we square root both sides, the result is plus minus. Square root of negative 1 is I. And then in the denominator, we're going to have square root of 5, which is not okay. So we're going to go ahead and multiply by square root of 5 over square root of 5 so that we can get the denominator to be a whole number. So we end up with I square root of 5 over square root of 5 times square root of 5, which 5 times 5 is 25. Square root of 25 is 5. All right. 23. On these, we are solving. And they are specifically saying we need to use the quadratic formula. Remember, the quadratic formula is variable equals negative b plus minus the square root of b squared minus 4ac all over 2 times a. So we need equals 0 to use the quadratic formula, right, to get our ABC. So I'm going to go ahead and add 18 to both sides. So I get negative 8m squared minus 8m plus 18 equals 0. And then I also want to factor out a negative 2. It's just going to make the numbers slightly smaller so that when I work with them, they are not as large of numbers. So negative 2, factor out, we get 4m squared plus 4m plus 9. Oh, actually, 18 divided by negative 2 will be negative 9, right? Okay, so now our A value is 4, our B value is 4, and our C value is negative 9. So let's go ahead and plug that into the quadratic formula. Now here the variable, the unknown is not x, it's m. So I'm just going to write m equals negative b plus minus the square root of b squared, so 4 squared, minus 4 times a is 4, times c is negative 9. And I'm going to extend the radical bar there. And then that's all over 2 times a is 4. Now simplify this by parts, right? So 4 squared is 16. Negative 4 times negative 9 is negative, negative times a negative will be a positive. So this is positive 144. And then 2 times 4 is 8. Okay. Now 16 plus 144 is 160, so we have negative 4 plus minus the square root of 160 all over 8. The square root of 160 simplifies, okay, because 160 is 16 times 10, and 16 is 4 times 4, right? So the 4 comes out. So square root of 160 simplifies to 4, square root of 10, and then we can distribute the division of 8 to both of them. So we end up with negative 1/2 plus minus the square root of 10 over 2. So that is the answer. All right. Let's move on to part B. So same thing, when you're gonna need equals 0, so I'm gonna add 10 on both sides. So we get negative 10b squared minus b minus 7 equals 0. And then on this particular one, we cannot factor out any GCF. So a is negative 10, b is negative 1, and c is negative 7. So here the variable is b, right? So we can write b equals, and then the coefficient of the linear term, negative 1, would be actually positive 1, plus minus the square root of negative 1 squared minus 4 times negative 10 times negative 7, all over 2 times negative 10. In the denominator, we would get negative 20. The number negative 1 squared is just 1, and then negative 4 times negative 10 times negative 7 is negative 280. 1 minus 280 is negative 279. So we have 1 plus minus the square root of negative 279 all over negative 20. Now, 279 breaks up. 279 can be divided by 3. We get 93, and then 93 could be divided by 3, we get 31. So a 3 comes out of that radical. 31 is prime. Also, the square root of negative 1 is I, so we get 3i square root of 31, and this is all over negative 20. And that's our answer. All right, part C, we need equals 0, so let's add 5 on both sides. So we have 4a squared plus 10a minus 11 equals 0. And then, so on this one, you can't factor out a GCF. So a is 4, b is 10, and c is negative 11. So here the variable, the unknown, is a. So I'm going to write a equals negative b is 10, plus minus the square root of b squared, so 10 squared, minus 4 times the a value, coefficient is 4, times the c value, constant is negative 11. This is all over 2 times coefficient of the quadratic term, which is 4. Now 10 squared is 100, so we have negative 10 plus minus the square root of 100. Negative 4 times negative 11 is positive 176. So this is plus 176 all over 2 times 4, which is 8. 100 plus 176 is 276. So we have negative 10 plus minus the square root of 276 all over 8. 276 does also break up. 276 can be broken up, divide by 2. We get 138. Divide 138 by 2. We get 69. Divide 69 by 3. You get 23. 23 is prime, so only a 2 comes out. The 3 times 23 will stay on the inside. So you have negative 10 plus minus the 2 that comes out times the square root of 3 times 23, which is 69, all over 8. Okay. Now all 3 of these terms we can divide by 2. So negative 10 divided by 2 is negative 5. 2 divided by 2 is 1, so this is 1 times 69, times, square root. And then 8 divided by 2 would be 4. So you can leave your answer like that. All right, last one, part D. Ooh, fractions. Well, let's go ahead and add 1/4 x to both sides. So I have 1/2 x squared plus 1/4 x minus 7 equals 0. And then we can go ahead and get rid of these fractions by multiplying by the least common denominator, which would be, in this case, 4. So multiply 4 on both sides. That's 0 times 4 is just 0, so that's going to stay 0 on the right-hand side. 4 times 1/2 is 2, so this is 2x squared. 4 times 1/4 is 1, so this is 1x. And then 4 times negative 7 is negative 28. So our a value is 2, our b value is 1, our c value is negative 28. The variable here is still x, so nice. We can just keep our variable as x. And so x equals negative b, negative 1, plus minus the square root of 1 squared, that's just 1, minus 4 times a, which is 2, times c, which is negative 28. That's all over the denominator 2 times a, and a is 2 in this case. So from here, we can go ahead and simplify. Like I mentioned already, 1 squared is just 1. Negative 4 times 2 times negative 28 is positive 224. So this is 1 plus 224, all over 2 times 2, which is 4. I have negative 1 plus minus the square root of 225 over 4. Now the square root of 225 is actually 15, right? So this is negative 1 plus minus 15 over 4. So we have two answers. We can actually break up this answer here because the radical actually simplified to a whole number, right? It simplified to a number, so we're able to break this up into the negative 1 plus the 15 divided by 4, and then the negative 1 minus 15 divided by 4. So this would be 14 over 4, which simplifies to divide 2 on top and bottom, 7 over 2. Then this one, negative 1 minus 15 is negative 16 over 4, which would simplify to negative 4. So those are the two solutions. You can actually break it up because the square root was a whole number. All right, let's move on to number 24. Okay, so on 24, for part A, we have the square root of 45, and the square root of 45, we want to break that up into 45 can be divided by 5. 45 divided by 5 gives us 9, and then 9 can be divided by 3, which gives us 3. So a 3 comes out of that. Obviously, this is also negative 45, so we have the square root of negative 1, which is I. So we have the square root of negative 1 times 5 times 3 squared. So the square root of negative 1 gives us I, the square root of 3 squared gives us 3, and the square root of 5 would just stay square root of 5. Okay, for part B, I'm adding up these terms. So the parentheses are not necessary because we're just adding this. The only time that the parentheses is necessary is because here negative 1, we need to distribute that to both of these. So remember when you're subtracting to distribute. So we have negative 7 minus 6i to the 5th power plus a negative 3. Well, plus a negative 3 is really just a minus 3. Minus 3i to the power of 8. And then negative 1 times negative 3 is positive 3. Negative 1 times negative 5i is positive 5i. Now, I to the power of 8, 8 divided by 4 is 2, remainder 0. So I to the power of 8 is equivalent to I to the power of 0, and I to the power of 0 is 1. So this is the same thing as 1. Then I to the power of 5, 5 divided by 4, 4 goes into 5 one whole time, and you get a remainder of 1. So I to the power of 5 is the same thing as I to the power of 1, which is, of course, just I. So this is just I. So you have negative 7 minus 6 times I minus 3. Negative 3 times 1 is just negative 3 plus 3 plus 5i. Negative 7 minus 3 is negative 10. Negative 10 minus 3 is negative 13. Negative 13 plus 3 is negative 10. So all of our whole numbers added up are negative 10. Then negative 6i plus 5i is negative 1i. And that is our solution. All right, for part C, we need to simplify this. Now, 10 over negative 4 obviously simplifies. Divide by 2 on top and bottom, we have 5 over 2i. But the issue is that the I is in the denominator. Remember, I is technically the square root of negative 1. So that's a radical. We can't have a radical in the denominator, so we're going to go ahead and multiply the numerator and denominator by I. Negative 5 times I will be negative 5i. And then in the denominator, I times I is I squared, which I squared is negative 1. So this is 2 times negative 1, which would be negative 2. So our final answer, negative divided by a negative is a positive. So we have 5 over 2i. Okay, part D, I to the power of 58. So 58 divided by 4. 4 goes into 5 one time, and we subtract, we get 1, bring down the 8. 4 goes into 18 4 times. 4 times 4 is 16, and we get a remainder of 2. So this is 14, remainder 2. Remember, the remainder is what matters. The whole number does not matter, just the remainder. So I to the power 58 is equivalent to I to the power 2, and remember, I to the power 2 is -1. All right, here we have 3 things multiplying together, right? Multiplication in between. So first, let's multiply the first 2 things. -3 times 8 is -24. -3 times 5 is -15. So this is -15I to the power 9. And then before I actually multiply that with 2 plus 3I, I'm going to go ahead and simplify I to the power of 9. 9 divided by 4, 4 goes into 9 2 whole times, and we get a remainder of 1. So the remainder is 1, so I to the power 9 is the same thing as I to the power of 1, which is just I. So I'm going to go ahead and erase that little power of 9 there, because it's just I to the power 9 is I. So now we can simplify. -24 times 2 is -48. -24 times 3I would be -72I. -15I times 2 is -30I, and -15I times 3 is -45I squared. Remember that I squared is equal to -1, so this is -48 plus 45, because -45 times -1 will be +45. -48 plus 45 will be -3, and then -72 minus 30I will be -102I. All right. Last problem, part F on number 24. We have here a fraction, right? So we need to get rid of the I in the denominator. So I'm going to go ahead and multiply by the complex conjugate, 1 minus 2I. So I'm going to go ahead and distribute. 5 times 1 is 5. 5 times -2I is -10I. 3I times 1 is 3I. 3I times -2I is -6I squared. In the denominator, 1 times 1 is 1. 1 times -2I is -2I. 2I times 1 is 2I. And 2I times -2I is -4I squared. All right, from there, I squared, of course, is -1, both here and here. So we have in the numerator, -6 times -1, which is +6. So that's 5 plus 6, which is 11. And then -10 plus 3 is -7. So that's -7I. In the denominator, -2I plus 2I cancels. And then -4 times -1 is +4. 1 plus 4 is 5. And that's our final answer for part F. All right, let's move on to the last 2 questions, 25 and 26. So on 25, we're finding the range of values of k that will give no real roots. Remember, no real roots means 2 imaginary roots. How do you have 2 imaginary roots? When the discriminant is less than 0. So we need the discriminant to be less than 0. Here are the values. A is 2, B is 3, and C is k. So A is 2, B is 3, C is k. So our discriminant, remember the discriminant is b squared minus 4ac. I need b squared minus 4ac to be less than 0. B is 3, so 3 squared minus 4 times A is 2, 2 times C is k. Has to be less than 0. Simplifying from here, 3 squared is 9, -2 times 4 times k is -8k. Subtract 9 on both sides, so we get -8k is less than -9. And then divide by a negative. Remember, when you're dividing by a negative on both sides with an inequality, you have to flip the inequality symbol. -9 divided by -8 would be +9/8. So the k value has to be a number greater than 9/8 in order for this equation to give you 2 imaginary solutions. All right, and then the last question, number 26, we're finding the discriminant of the quadratic equation and then determining the number and type of solution. So I'm going to go ahead and subtract 6 to both sides, so we have -6x squared plus 12x minus 6 equals 0. Okay, remember we use A, which is -6, B, which is 12, and C, which is -6, and the discriminant is b squared minus 4ac. Okay, so b squared would be 12 squared minus 4 times a, which is negative 6, times c, which is negative 6. 12 squared is 144. Negative 4 times negative 6 times negative 6 is negative 144. 144 minus 144 is 0. So that is the discriminant. The discriminant equals 0. And then what does that mean? If the discriminant equals 0, that means that when you add and subtract, you're adding and subtracting the square root of 0, which the square root of 0 is just 0. So you're adding and subtracting 0, which is not going to give you two different answers. It's going to give you one repeated real root. And that's all she wrote. All right, hope it was helpful, and I'll see you guys in another video.